Okay, the rest of the slides up until the lab and homework assignments are not as complicated or as critical as the ones that were immediately before, but they do have some real interesting and useful things to know about lists. For instance, if you just need a list of numbers, you can take range and run a list function against it. That will produce a list of numbers then. Same if you have a string. You can run the list function against the string. And this one here will go to an error. You can't run the list function against just anything. It has to be something that is listable. Okay? So in this case, you would have to do something a little bit different to get that to work. But let's look at what happens with at least these top two here. That creates an empty list, but these top two, I think, are something that you might use. And basically, you know, here's a list of numbers. I know we do use that later on in the course. And here's a string. Because if we wanted to operate on each letter independently, putting those letters into a list would open up the whole world of list methods then that we can use. Alright, so there's some reasons why we might want to turn things into a list. That's what the list function's for. Here, I had shown this back when we had Color Mixer, is that there's a way to check if something is in a list. So when we have our villains list, we could say if Darth Vader, you could say in your mind, is in the villains list, then do something. Print Darth Vader's in the list. Otherwise, say Darth Vader's not in the list. Okay? So that one I had shown before when I had, you know, if the person's first color is, choice is not in the list, you know, I want to send an alert out, ask them again. Okay, so the in operator, that also works with strings. You can check and see if a letter is in a string. And so that's very, very useful. I'll let you run that code on your own. How about if you want a list of zeros for some reason, or a list of anything repeated, you can use multiplying, and that will generate quantity for you. Many times you have two lists, you need them to be combined. Well, here's a nice little program. My bands are there, my friends' bands here, but we want a road trip playlist. We could add, you know, use the addition operator to add those two lists and create a new one, road trip playlist for the both of us. All right, that's a pretty nice little operation there to save that code. The next section is about removing things from lists. Remove versus pop versus delete. You'll find if you were just to go out and research how do I take something off a list, then you know, you would run into these three methods. So these slides explain a little bit the differences. Pop is good because it removes an item, but it also returns that value so you can save it in a separate list if you want. So like with our guest list, if we wanted to save the people that we had deleted in a separate list in case we have more room, we want to put them back in, then pop is the method for that purpose. Remove, you need to know the exact spelling of the item. Okay? So these will fail if you try to remove an item and it's not there. So I gave you a link to a Stack Overflow article that's pretty helpful on that. So let's take a look at this. I have my guest list in memory, and so when I look at pop would be without a number, would remove the last guest. Okay, so, sorry Frank, Frank's gone now. But I'm saving his name in the uninvited. Uninvited equals guest.pop. Okay, so guest.pop returns the one it's taking out. Here, if you put a number in here, that's the index of the person you want to remove. So if I do index 1, then, Bob's coming off the list. All right, and Bob would then be saved under next second guest, and I could take those deleted people and build up a new list if I wanted to. Okay, so that one doesn't come up so much in this particular lesson, but it does come up as we go along, where you need to know how to remove things from lists. All right, and in this case, it would be better safe than sorry. Before you do remove or pop or delete, put it in a conditional. If Sauron is in the guest list, go ahead and remove him. Or else say there is no such guest. Okay, so that would be safer than just running pop or delete without checking first. And so, in my case, Sauron's not on my guest list to begin with, so I would get this nice little message. Don't worry, he's not on there. Okay? So that is removing items from lists. You might recall that I had my list of students up here, and I was basically getting a group of 3 randomly selected, and then at that point I would want to get rid of them off of the pick list because they're already in a group. So as soon as you're working with lists, you may have an operation where you need to do removals. That's in real life. Okay, and then sorting. Sorting is nice. You can sort your list. I also did that on my list of students. And just bearing in mind that it sorts into ASCII-betical sorting. That means, if you recall, our ASCII table is that the capitals are in one section and then the lowercase are in the following section. So if people in my guest list didn't capitalize their name, they would appear to be out of order by this sorting. So you have to maybe first take care of capitalizing on your list, which you can do. We will look more into that in our chapter 6. Or at that case, then sort after you have corrected capitalization. Numbers will also sort. If you sort in a list that has numbers and then letters, it will sort numbers first, then letters. So sorting. Copying. Sometimes you would need to make a copy of a list, and this is how you do that. We got data as a list, and then copy of data equals data, and this appears to be an empty bracket, but what it really is indicating the whole list. If I were to do copy of data and put numbers in here, like start at list item 1 and go to list item 3, that is called a slice. Okay, and that was shown on a previous slide, but the reason we're looking at this again now is because with copying, if I remove an item from the copy, so here's copy of data dot remove the 8. Okay, if I do that, then this is to show us that the 8 will still be in the original. It will not be in the copy anymore. So when you make a copy, they're truly independent. And sometimes you want a separate copy before you start doing removals. That's the situation with that. The different situation shown on the next slide is aliasing. So here I have a list called data. And then I have alias of data equals, and you simply mention a list name here. So I'm basically saying my alias it's not a copy exactly, it's more like a view into that list, separate, under a separate variable name. If I was to remove an item, the 8 from the alias, we will find it's gone from both copies. So this is like syncing versus backup, you could say. Like here, you're actually backing up your data, making another copy. And if you edit one, the other one's still intact. With this one, it's like syncing where, it looks like you have two, but basically they are linked together. And there is a list ID behind the scene that is doing that linking. Okay, so just to wrap up, is that the lists you're going to find are very useful. They can be frustrating at times while you're learning, but you just come to depend on them a lot. They're great for driving loops, for one thing. So a lot of repetitive actions can be done using lists. You're going to see a lot of them. And so when we learn, even a little bit more than we need for the lab and the homework, that's for the better, because it will come up later when we are just using lists, as a matter of course. And the programming majors are the ones that need to understand the difference between copying and aliasing. All right? So there'll just be one additional video on our lab and homework. There is a sample program. It's set up different, than we're setting it up because it came from Andy, but I think it's worthwhile to look at an extra sample. Thanks, bye.